Good evening, everybody. On behalf of my colleague Larry Ahern, Vice President of Chapters, I'm Bert Dicht, Managing Director of Membership. Welcome to our Space Forum this evening, Chasing New Horizons, a conversation with Dr. Alan Stern. So again, we thank you for joining us in our series of Space Forums. We're looking forward to a really fun and interesting session this evening. I always like to give a little bit of a rundown of what we're doing, and then we'll get into the program real quick. I start off with some virtual etiquette. We'll get into a few NSS announcements, then talk about what's upcoming with the space forums and town halls, and then we'll get right into the program. We will be ending with the virtual door prize. Remind everybody, in order to win one of the 4 books we'll be giving away, you do need to be present. So hopefully you can hang on till the end, and then we'll close out the session. In terms of our virtual etiquettes, feel free to submit a question using the Q&A function. It's best to use that because it's much easier to pick out the questions so that we can funnel that to our speaker and so on. But feel also free to use the chat function. But I do ask that you be respectful of panelists and the audience because pretty much everybody can see that. And we will try to go through those as well to try to pull the questions out. We did get a lot of questions that were submitted. We're going to be doing mostly just a conversation this evening, and we're going to try to incorporate them into the discussion. But of course, feel free to ask questions as well during the session. If you'd like what we're doing here in terms of our programming and supporting the National Space Society, I urge you to give to our cause. Feel free to donate and it really helps in supporting all of our programs and activities. We really appreciate the support we've received in the past, and I thank anyone in advance who makes a donation this evening. Also, at the end, you will be moved to a survey. This is our post-Space Forum survey. It's completely optional and anonymous. It only takes a few minutes to complete. So I would ask if you have a chance, do it. And it really helps us in terms of planning future events. So thank you in advance also for that. So what's coming up with our Space Forums? On November 9th, we have Chantel Beyer, who's going to be talking about a payload that she's working on that is going to be carried on Intuitive Machines Nova-C moonlander. That'll be launched on a SpaceX Falcon 9. It's tentatively scheduled for around November 15th or November 16th, and we hope to have a better idea at that point, and we'll give you a rundown on what that's like to get a payload on board. On November 30th, we have the Space Ambassadors and a debate on robotic space exploration versus human space exploration, an interesting debate. December 14th, we'll have the Year in Space with Larry Boyle, something we do on an annual basis. We are still trying to see if we can squeeze in one more before the end of the year. As topics are coming up, Mike Snyder, one of our board of directors who helped found the Made in Space company, and 3D printing on the International Space Station. He has a great presentation, so we hope to present that. Also, a NASA representative from the Marshall Space Flight Center talking about the Parker Solar Probe, a planetary geologist on planetary exploration, and also an expert from also the Applied Physics Lab talking about the Webb Space Telescope, and Jonathan Ward, who was on before, who co-wrote the book with Eileen Collins, is going to be talking about his book, Bringing Columbia Home. So hopefully we'll have a pretty good calendar for you leading into the new year, but a lot of exciting upcoming presentations, and I hope you can join us. So now I want to just move into the program. Before we start, I'd like to just introduce our CEO, Anita Gale, to give a quick welcome. I'm going to stop sharing for a second so you can see her on the screen. Hi, Anita. Thanks for joining us.
Hi. Yes, my pleasure. This is one of my favorite things to do in NSS. And I'm not going to say much because this is for NSS is a really exciting program. This program was, or the spacecraft was or the team that runs the spacecraft was threatened with cancellation, elimination of the NASA budget. And NSS had people prowling the halls of Congress, literally talking to congressional staff and Congress people, and explaining why it's very, very important to keep this satellite going. So I'm not going to say any more. I want to get into this and see what we help make happen. Thank you.
A perfect lead in, Nita, for our next speaker. So it's also a great pleasure this evening to have our executive vice president from NSS, Hoyt Davidson. Hoyt led the change.org petition called Save New Horizons. And I went onto the website today just to see what it had. So it has this victory sign that they put onto the website, and we got about almost 7,100 people signed the petition. So Hoyt is here to just tell you a little bit about how it all came to be, and of course it was a great success. So Hoyt, welcome and thank you for joining us.
Thank you, Bert. And I have to say this was a very interesting experience for a lot of us. Certainly on-the-job training or learning, because we had never done anything like this as an organization. Alan had made us aware, I think in the summer, of the defunding of New Horizons. We were kind of shocked that the team was being kind of treated this way, given all the successes it had with Pluto and the Kuiper Belt. Spacecraft was still working great. The team was together. A lot more science to do, billion-dollar type spacecraft that it'd be 20 or 30 years before you could get someone else out there to finish the science. And it just didn't make any sense to us at all. So we agreed to try to help out and turn around this decision, but really didn't know how to do that. We started off attending a town hall with the Science Mission Directorate, and that went nowhere. Trolling the halls of Congress, and that sort of didn't get us very far. And then we decided to be activists and do a change.org petition, and got that started. And if you've ever done one of those, it's just a learning experience and improve it and keep the momentum going. We added our friends at the Space Frontier Foundation. We added our friends at the Beyond Earth Institute, and just I was really pleased and even shocked at how much momentum we ended up getting. Not only did we have almost 7,100 people signing it, and I got to tell you, when we started this, we were hoping to get like 1,000, maybe 2,000. So 7,100 kind of blew past all of our expectations. But also people were sharing it within their networks. They were contributing dollars to help fund this. It was just really heartwarming to see the great support, because Alan and his team really deserved it with all the great things they did. And we couldn't be more pleased to be, a small part of hopefully helping to change the minds at NASA to overcome this decision. But with that, please, we'll let Alan take the helm here.
Very good. Thanks so much, Hoyt, and congratulations on a great job. We really appreciate that effort. So let me get back to sharing my screen, everybody. And so now it's time to introduce our guest speaker for the evening. And I think most of you are here tonight because you actually know who he is already, so I won't spend too much time on the introduction. But Alan is Dr. Stern. Alan is an aerospace executive and a planetary scientist. He has more experience of more than 29 space mission teams, about 14 of them which he played the role of the principal investigator, and also a career at NASA, associate administrator for the science directorate as well. He spent a lifetime actually is affectionately called Mr. Pluto, and that's why we have him here today. You know him as the principal investigator for the New Horizons spacecraft that went out past Pluto and into the Kuiper Belt, and of course is now going to be continuing because of this NSS effort. He's also, and maybe he'll be able to talk a little bit about that as well. Today, just announced that he's going to be flying on Galactic 5 mission on Virgin Galactic Spaceship 2 in November as astronaut 20, I believe. So maybe we'll hear a little bit more about that. So without any further ado, it's my pleasure to introduce Dr. Alan Stern. So Alan, thank you for joining us. Welcome.
Thank you, Bert. It's great to be here. Thank you for inviting me. And I have to say thanks to all the folks at NSS. Really an honor to work with you guys. And Hoyt was really the point of the spear in this, but carried it off so effectively and really made the difference. I really felt that our mission was besieged and that we were a little bit like Custer at a last stand. And the difference is, in our case, the cavalry rode over the hill and it was carrying the NSS flag and saved the day for us and made all the difference. I'll be forever indebted.
Very good. Yeah, we were really excited. So let's start talking a little bit about the program and a little bit about you. One of the things I found in your book, you open it up with what could have been a disaster. You start off with what happened on July 4th, 2015, that you lost contact with New Horizons and you rushed to the Mission Operations Center, and it turned out to be exactly like some of the experts thought, that the computer was overloaded and just needed to reboot. But you had a lot of emotions at that time, that thinking about the 14 years you've worked on it and the 2,500 people involved. And so the question I have really to start out, when you work on a project like this, we as engineers, sometimes if something goes wrong, you can fix it right then and there. But you've sent this thing out on a couple billion mile journey, and if it doesn't work, everything is gone. And so what kind of mindset do you need? Because you've worked on most of your projects like that in space exploration, to do these things where one and done is not a good thing if something bad happens.
Well, I have worked on a lot of space missions, none of them as far away as New Horizons. And I've even been on a couple that went really, really south on us during launch or for other reasons in flight. It's so easy to fail in space flight because so many things have to go right. It's so easy to have one thing go wrong that maybe in hindsight, it was easy to look back and say, well, we should have realized that. The whole trick is in these big teams is to weed out all the problems to the point where it does succeed. In the case of New Horizons, that weekend of July the 4th, 2015, we had flown that spacecraft really without any significant incident for over 3,000 days to cross the solar system. And here we were 10 days from the flyby, precisely 10 days. And all hell broke loose with no warning. And I got to say, at that point, you're almost out of time, particularly when you consider that even just to send a signal to the spacecraft to ask it to send you a data dump, a telemetry report, and to have that come back takes, in that case, in 2015, 9 hours round trip just to get a little more information about the nature of the problem. And every time you make a chess move to resurrect the spacecraft and get it operating again, and then to upload all the plans, every one of those chess moves takes 9 hours. So there's not a lot of 9 hours in basically 9 days. But what made it even harder was the fact that the flyby wasn't all just on the closest approach day. It actually started only 3 days after this catastrophic failure occurred. We only had 3 days to save it without losing anything. And thanks to our engineering and mission ops team, and just incredible talent on that team and incredible dedication, they pulled it off. And they made something very hard actually look easy. And they put Humpty Dumpty back together again, and we had a successful exploration of the Pluto system.
Fabulous. I want to start talking a little bit about your background. You're, like a lot of us, you're a member of the Apollo generation. And it was just fun to read about the fact that you were so excited about watching an early Apollo launch that you wanted to get a copy of a flight plan from NASA. And you wrote NASA a letter. They said, well, unfortunately, we can't give that. You're not a journalist. And you end up writing your own guidebook. What did you, that I thought was really fascinating. And you actually were able to make a connection with a NASA public affairs individual. I think your book was called The Unmanned Spacecraft, An Inside View. And you ended up being able to get some flight plans from NASA. So really a great start. Is that what led you to your career in space?
Well, it certainly was a big enabling factor. I was hooked on space before that happened. And, I remember growing up watching all the Apollo missions were covered on TV endlessly, and I couldn't get enough of it. And I would write NASA like a lot of little children did. And they'd send me pamphlets on spacesuits and food in space and maybe how you do a spacewalk or something. But, it seemed like I just kept getting the same information and not in the technical depth that I wanted. And I maybe I was just too nerdy, but I wanted a lot more than they would send me in these pamphlets. And one day on a Apollo broadcast by Walter Cronkite, those who remember Walter Cronkite, he was holding up this technical manual called the flight plan. And I thought, that's what I'm looking for. I want to see the inside of how this thing works. So like you said, I wrote and asked, and they said, no, sorry, we only print so many of them in those days. It wasn't like PDF where you just pass them out to anybody who wants to click. And they said they only have so many. And if you're not accredited press, you can't get one, kiddo. And I said, what's it take to be accredited press? What did I know? I was 13 years old. And he said, the head of Johnson Space Center's public affairs, a guy named John McLeish, wrote me back, and he said, you got to show me some published articles in real magazines, or you got to show me a book that you wrote. And I thought to myself, I have no idea how to get a magazine article published, but I guess I could write a book. So I spent a summer doing that. And my grandfather's secretary typed it up in triplicate with carbon paper back then.
Right.
And I sent it to McLeish. And lo and behold, he sent me a stack of technical manuals. It was, the brain food equivalent of crack cocaine for me. It just completely turned me on. Like, this is the real stuff. This is what I want to do for a living.
Fabulous. I want to bring up a picture from your past here. So let me share my screen again, and I'm going to let's see. Here we go. And I put together a few slides here, and the one I want to bring up is a copy of a National Geographic from 1970. And in the book, again, you talk about reading this issue of National Geographic, Voyage to the Planets, where it talked about the Grand Tour. Mm-hmm. And there was a listing of things we knew at that time about the planets, the outer planets. And Pluto is on that list, but mostly there were question marks related to Pluto. So was this the beginning of your I guess you mentioned about Everest and conquering Everest. Was this the beginning of your plan to conquer Pluto?
Well, I wish I could say yes, but no, not really. I remember reading that and reading it over and over again. That whole, it was beautifully written, and it was full of facts about the planned exploration of the outer planets. In 1970, that had never happened. There had been spacecraft to Mars and Venus, and that was about it. And even the pioneers were in the future, And I read about all this and all these faraway dates in the 1980s and so forth, and it just seemed like forever away. And they had a table of what we knew about all the planets, and as you got farther and farther out, they knew less and less, of course. And so they just put more and more question marks. Pluto was just about all question marks. And I never really thought about growing up to be involved in the exploration of Pluto. I just wanted to find some way to be involved in space exploration. But it did make a big enough impression on me that years later, when I did get involved, I went to an old used bookstore and found one of these National Geographics with this story in it, and brought it home just to keep it, because I remember it being so impactful when I was a adolescent.
Wow. And so it led you to, you started out as actually an engineer, and then actually decided to go back and become a planetary scientist. Tell us a little bit about what a planetary scientist is. I saw there was a question that was submitted from a teacher, and the students wanted to know specifically, how do they become a planetary scientist and get to work on future missions like New Horizons? So what led you to that?
Well, my interest in space exploration ultimately led me to it. And I had a hard time deciding whether I should be an engineer or a scientist. And I tried both out, and it turns out I liked the scientific side better. I was originally an astronomer. I studied astronomy as an undergraduate along with a degree in physics, and then I got a PhD in the field. But I never really wanted to do astronomy. I really wanted to study the planets because they're much closer. They're much more accessible, and it always seemed to me that we had this running pattern all across the initial exploration of the solar system, that everywhere we sent a spacecraft, the first flyby reconnaissance showed we were completely wrong with everything that we thought from the Earth. And we didn't get Mars right, or Venus right, or Mercury right, or Jupiter right, or the satellites of Jupiter, and on and on. And it just convinced me that trying to do something like astronomy and really ever have a chance to find out what places were really like was impossible through telescopes, that you had to go there. So I should be in the business of flying spacecraft to the planets where you can really, the rubber hits the road and you find out what's going on. And that's what convinced me to be a planetary scientist. For those who don't know what that field is, it's the study of the planets and other bodies, the smaller bodies in our solar system. And one thing I really like about it, besides the exploratory aspect and the fact that you can actually find out if your ideas are right or wrong, because we send spacecraft there with sophisticated instrumentation, I really like the fact that it's so interdisciplinary. That within the field of planetary science, we have lots of geologists and geophysicists, and we have lots of chemists and meteorologists, and we have people who know how to use telescopes and know how to use spacecraft, and we have people that are theorists that write big computer models, and it's really this cauldron of different sciences that it takes to understand the planets and the formation of a solar system. It requires so many different skill sets that nobody can be expert in all of them, and it takes teams to solve problems. And I just liked all those aspects of it. And I have some expertise in some narrow areas of planetary science, but I think all the big things that I've worked on were team efforts, and there's nothing better than that for me.
Did being an engineer first give you some added insight to being a principal investigator? Because you're obviously developing a spacecraft to do a lot of things, and having that engineering background probably added an extra perspective.
I like to think it did. You're right. I like sitting in on engineering meetings. I enjoyed being an engineer, even though I enjoyed being a scientist more. I know a lot of my colleagues who've been at the heads of missions or even instrument investigations. They want to leave it to their project manager and the engineers to figure out all those details. They want to make sure that the science is going to turn out right. I think that my background in engineering, my interest in it, made me a lot more comfortable probing to make sure that we got things right than others who left those details, if they were, to their project managers. So I'd like to think that it made me a better scientist and a better principal investigator. It certainly made it a lot more fun doing that kind of stuff. because I always felt that the professional engineers had way more skill than I ever had as an engineer, but that I understood their language and their culture enough to be able to hold my own and to ask the hard questions and sometimes make design changes to maximize the probability of success.
Right. When did as you made the transition to planetary scientist, when did your interest in Pluto arise then? What got you first? What was that first spark?
When I was just starting grad school, I was looking for a thesis advisor, and the department chairman at the school I was at, the University of Texas in Austin, department chairman was a man named Harlan Smith, who had been my mentor. He was also the director of McDonald Observatory, and he was really a dean in the field. And this was in the late 70s and early 80s, and he knew that I had an interest in the solar system, and he sent me down to work with a young hotshot Caltech scientist who was at the University of Texas named Larry Trafton. Really brilliant guy, super athletic, and had done some spacecraft missions in addition to a lot of ground-based astronomy. And Larry had been a candidate to be an astronaut back in the 60s and the early 70s. And Larry had a particular problem he was interested in to understand escape processes in Pluto's atmosphere. And he asked me if I would want to work on something like that. And I said, well, I don't know anything about Pluto. And he said, that's all right. Nobody knows anything about Pluto. It's wide open. And, almost everything you discover is going to be new. It's not as constrained as working on a place like Mars, where we've had 6 missions by then to Mars. And that's what really got me hooked, was doing that project. And of course, 25 years later, we were launching a spacecraft to go explore Pluto.
Tell us a little bit about what's called the Pluto Underground and how that came to be.
We stole that term. That's the truth. Back in the very early 80s, before I was really in the field, there were a bunch of young grad students and postdocs who really want to see NASA amp up its Mars exploration efforts. And they formed something called the Mars Underground. And they were rabble-rousers, and that they really made a difference. They were fresh faces and brilliant people and hardworking, and they consider themselves sort of in guerrilla warfare to bring the exploration of Mars to a whole new level. And they were very successful at it. And these are people that were 10 years older than my cohort. So we felt like children, and they looked like adults to us. But when it came time to try to get a mission to Pluto, after Voyager had done everything but Pluto, and we needed a model, we adopted the Mars Underground model and called ourselves the Pluto Underground. And that's how it got started.
And you talk a lot in the book about the many starts and stops that NASA had about the Pluto mission, and costs and that type of direction. And one of the things I think that really hit me was the kind of the public perspective versus the internal. And you talked about it, that NASA, from a public relations standpoint, is always about to boldly go, to explore, that type of thing. But when you're inside and trying to get a mission planned and approved, it becomes a real competition and struggle, because you're dealing with finite budgets, and you really have to make strong cases for the science. So and prove the value. So it's a whole different aspect from the same agency. And I just found that interesting. And, probably from your standpoint, took a lot of perseverance and frustration as you're dealing with all these yes, no type of things.
No question. It was tormenting. That water torture went on for 14 years. Before we finally succeeded. We just couldn't find the right key to open the lock. We tried a lot of times when we got close. And it was this strange dichotomy where the agency, rightfully so, prides itself on being an exploration agency. And yet, when you're trying to win the case to spend limited dollars on doing one thing, in our case, we want to go explore Pluto, versus all the other things you could do with that same money, it was never about the exploration value. You couldn't go to a NASA advisory committee and talk about, well, we're going to do the farthest mission ever done. We're going to go to the last remaining frontier. We're going to go to a whole new type of planet. You had to make these very detailed scientific arguments, which of course are important, and you have to be able to compete in that scientific marketplace. But the fact that all of the exploration ethic and all of the exploration value in doing something like any given mission, but particularly going, to what I used to call the Everest of planetary exploration, Pluto, was completely left off the table. It's as if you can't talk about that. You can only talk about, why the atmospheric escape mechanism of hydrodynamic escape that may be occurring at Pluto, it can inform us about the early evolution of the Earth's atmosphere, or why the melange of different supervolatile ices on the surface has important parallels to other bodies we've been to and don't understand, like Triton and Titan. And these narrow scientific arguments, they are important, and you have to be able to rise to the top in that. But it just astounded me, having been a kid that was inspired by exploration, that the exploration topic, which is the way the public perceives NASA, is all about exploration, was not a legitimate topic to bring up in this competition. In fact, if you brought it up, it would undermine your case, because some people would say you're not confident enough in the scientific case. You have to bring up these crutches of exploration. And I just found that, I still find it short-sighted, because they're both important. It's not a question of should we only explore, should we only do science. It's really, how do we get the maximum value for the budget that we have? And both motivations are important, in my view. Right.
One fun story in the book is about this student, Ted Nichols, who kind of led an independent effort to get NASA to approve the Pluto mission. And I love it that you talk about it, that he was, went to NASA headquarters and he's grilled by some NASA officials, like, who do you work for and what are you doing here? But it's an interesting story that it kind of maybe, I don't know if he tipped the balance, but at that point, a Pluto mission was becoming more real. And I was just wondering, did he ever become a planetary scientist or an engineer in space? I'm just wondering what happened to him.
Sure. Well, Ted was an amazing piece of the puzzle of putting together. He just came out of nowhere, and by accident, he was a kid that was growing up in eastern Pennsylvania, I think, if I remember right, near Hershey, Pennsylvania. And we were pretty vocal in working with the Planetary Society and others and trying to get funding to do a mission to Pluto. And there were a lot of articles in the press and in the Astronomy Magazine and Sky and Telescope and Aviation Week and all those places. And Ted saw all that, and he saw that it was kind of not happening. And for whatever reason, he was 17 or 18 years old, and he got highly motivated to go talk to people at NASA and say, well, I'm nobody, but I think that we should be doing this. And he found his way to Washington, D.C., 18 years old, and knocked on doors in NASA headquarters. I have no idea how he got past the guards, but he made a very vociferous case. And for some reason, his case got picked up by reporters. Here was this 18-year-old kid who's, like miffed that we couldn't go exploring Pluto. And he started getting more and more attention. And some of the NASA executives of the day, this is like back in the year 2000, hauled him into a room and started grilling him. Who's paying you, kid? Who paid for your travel here? Who put you up to this? Is it that Pluto Underground? Are those guys like buying your plane tickets or bus tickets or whatever? He's like, first of all, you're all my parents' age. I'm completely intimidated by you. But second, no, I just made some money during a summer job. I just came down here because I wanted to know why you're not doing this. And it completely shook them up. But he became kind of the poster child.
Wow.
For like the public. And then and he contacted us, and of course we worked together, and he played an important role. But he went on to a career in the military service. He's now a nearly 40-year-old man who's gone off to work in the private sector. He's not a scientist, not an engineer, definitely a space program supporter, but a kid that really, I mean, not a kid now, but then he really made a real difference. And he was like I was when I was 18. He didn't even look his own age. He looked like a real young kid, even though he was 18. He looked younger than his years, and he was just so likable, and such a great persona around him. You couldn't help but want him to succeed. He was that kind of a kid.
Great story. Great story. So the decision is finally made to have a Pluto mission, and you're a prominent person that both sides wanted. When I say both sides, the decision whether JPL should do this or the Advanced Physics Lab at Johns Hopkins, and you made a decision to go with APL. And you said they, of course, were the underdog. What were the deciding factors that led you to APL?
Well, it was a very difficult, what you call a Hobson's choice. In those days, there were only two institutions that had any experience in the United States doing missions to the planets. The Jet Propulsion Lab was the incumbent. They'd done the first mission to every planet. They'd done every planetary mission the United States had ever done had been either JPL or another NASA center, except for one that the Applied Physics Lab had led. And that was a mission to a very close asteroid. In fact, the mission was called NEAR, which stood for Near Earth Asteroid Rendezvous. So, if you just looked at the qualifications, it was clear that JPL was the Goliath to APL's David, but APL wanted it more, and they wanted to break into the big leagues, and I sensed that. And when NASA announced there'd be a competition, the director of JPL, Planetary Exploration, called me and said, "Will you lead our proposal?" And within hours, the head of Planetary Exploration at APL called and asked the same thing. And I thought, I got to make this decision, and quick, because within days we have to form a team. There's a clock ticking. And so I went home and I wrote down 3 questions. I decided I'd call them both back and ask them the same 3 questions. And I did that, and without taking too much of your time, all the answers that I got from APL reassured me, and the JPL answers really didn't. And on paper, JPL was the only place to go. They were the hands down favorite to win. They had more experience. They were the safer choice to NASA. But ultimately, I decided to go with APL, and I never regretted that decision. It was a great relationship. They built a spectacular mission. They did it on price. They stuck with it when the chips were down in many different ways. And here we are, 22 years since that decision, and that spacecraft is operating perfectly at the frontier of our solar system. To think they had never done anything but a mission basically around the block to an asteroid, and they could pull this off, I still pinch myself that the quality of the engineering and the pride of workmanship and the can-do spirit at APL that pulled that off. And they've done so many important missions since that I think in many ways, maybe not in every way, but in many ways, they've become JPL's equal. I even think that JPL has learned from APL the way that APL and all of us learned from JPL. And they're both spectacular organizations, don't get me wrong. I've been on a lot of JPL missions. I love working with them. But in this case, APL was the right choice.
That's a great lead in. Let's talk a little bit about the spacecraft. I think I'm going to bring up one of the slides here, and let me just do that. let's go back to our list. So I've got a diagram here. Can you tell us a little bit about the spacecraft itself?
Yeah, sure. Absolutely. So this is New Horizons. For scale, that spacecraft, fully fueled, weighs just a hair under 1,000 pounds. The dish antenna is a good, scale bar on it. It's 7 feet across. So you see the whole thing is pretty small, like the size of a baby grand piano. Off to the right, that cylinder that's black, or maybe it looks like, to me, it looks like a hair curler. It's not a hair curler. It's a nuclear power generator. That's what provides all of the electricity to run the spacecraft, which is not much. When we launched it, it was 250 watts, so about 4 light bulbs worth. The antenna, of course, is the communications device. Inside of the box that is the spacecraft are all the subsystems, propulsion, guidance, and navigation, and the main computers, and power distribution, and thermal control, and all the things it takes to run it. And there's 2 of everything, kind of like Noah's Ark. The only things that we didn't twin were the scientific instruments, which are on the outside, and that nuclear power generator, because we couldn't afford to. One was enough power to do it. But very sophisticated spacecraft for its day, very large solid state memories, particularly for that time, and a very agile spacecraft that could quickly maneuver as we flew through the Pluto system at this blinding speed to look at Pluto and all of its different moons as we were whizzing through and get all the data sets that we needed to get.
I think I've got a couple. There's an artist concept of it, and I think I've got a couple photos there of doing some systems checks. You mentioned the RTG, the thermoelectric generator. In the book, you talk about the challenges of getting that cleared for missions, and what were some of those things that you needed to make sure you can incorporate that type of system into the spacecraft?
Well, first of all, there really were 2 challenges for the RTG. The RTGs have been pioneered back in the 60s, and the one that we used was a spare from the Galileo and the Cassini programs that had come in the 80s and 90s. But anytime you launch nuclear material on a rocket, there are people who are worried, and rightfully so. Rockets sometimes don't work and they go in the ocean, or worse, they even rapidly disassemble in some cases. And no one wants nuclear material dispersed over even unpopulated areas. So in order to get permission to launch, you have to prove to a wide variety of different state and local and federal agencies that what you're doing is safe, and that even in the worst situation, that nuclear material will stay contained inside more or less the tank that is the RTG. Now, back in the 1960s, when these RTGs were first built, there was a launch at a Vandenberg Air Force Base in California that detonated and blew up everything. And the RTG landed in the ocean intact. And they took it out of the ocean. It was still working. They later flew it on another spacecraft. That's how well they're built. But nonetheless, every time you launch one, you have to go through this process that goes all the way to the President of the United States and all the way down to like Brevard County, Florida, right? And the city of Cocoa Beach, and the state of Florida, and the Coast Guard, and the Department of Energy, and the Environmental Protection Agency. And we took account. We had to get permission from 42 different state and local and federal agencies. And there was no boss of all 42. Even the President of the United States only is responsible for the federal government agencies. And, you heard that saying about, it's like herding cats. I used to say, this is worse. This is 42 cats hurting themselves. It was a complete, it was a maze of bureaucracy to get through all those check marks. But ultimately, and led by a brilliant guy, Glenn Fountain, who was also our project manager as we were building and flying New Horizons, he got it through that whole sticky wicket. And and got all the launch approvals. And of course, the launch was completely successful anyway. So all that was out of an abundance of caution. But you couldn't get permission to light the fuse without all those signed pieces of paper.
Right.
The other thing, you said, what were the challenges? The other challenge was during the, in order to make the RTG work, it has to be fueled with this plutonium dioxide. That stuff is produced at Los Alamos National Lab. It's only produced at a fairly slow rate because it's complicated to make this stuff. And while the plutonium was being produced for New Horizons, Los Alamos suffered not one but two multi-month shutdowns, not due to our fault. One was a security breach and one was an OSHA violation elsewhere in this big lab with hundreds of buildings and thousands of people. But every time they shut down the lab, they shut down our production line. And we're like watching the clock, because if we didn't get launched in January of 2006, it was pretty much game over. So we had to get that plutonium on time. And not enough power means when you get to Pluto, you have a brownout at best on that spacecraft. So it was really touch and go in getting the amount of plutonium it took. In fact, we didn't get everything we wanted, but we got enough to get the job done. So someday when New Horizons dies because of power starvation, probably around the year 2050, I'll be long gone. But people who are there, if they're space buffs, they might remember that I told them this. Had we gotten all the plutonium that we originally planned, we would have had power to sail into the 2060s, maybe longer.
Wow.
But I'm very happy that we got enough to get the job done at Pluto and the Kuiper Belt, and even a little more.
Navigating 3 billion miles is easy. It's navigating the people on Earth that's the tough part, right?
No question, that's the harder bit. I used to just say, the sooner we can get this thing launched and out of the hands of human beings, out of the Washington Beltway, the better off we'll be.
Right. One of the great stories is the connection to Clyde Tombaugh. And I just want to bring up that picture. And I don't know how many people know the fact that that New Horizons carried some of his ashes. And can you just tell us a little bit about that story and how that came to be?
Sure. Well, we spent a long time, we talked about this earlier, trying to get a mission to Pluto. In the beginning, which was the very late 80s and the early mid 90s, Clyde was still living. He died in 1997, around the time of his 91st birthday. And he knew that there were a bunch of young people who were trying to get a mission to Pluto, his planet. And one of those people was named Rob Staley, very talented guy at the Jet Propulsion Lab. It's before there was a competition between the Applied Physics Lab and Jet Propulsion. JPL was doing all the studies. Rob became the study manager, the chief engineer and project manager for getting the hypothetical spacecraft to Pluto. And Clyde Tombaugh took a liking to him, and they formed a kind of grandson-grandfather relationship. And along the way, I don't know who brought it up, whether Rob did or Clyde did, but they had a conversation about if we ever get a spacecraft to Pluto, Clyde had said he would like to have some of his ashes put aboard. And I was the study scientist, and Rob told me that he had had this conversation down in New Mexico with Clyde Tombaugh. And I just filed it away. I didn't think much about it. And then, maybe it was 10 years later, we were building New Horizons. Now I was in charge. We getting close to launch. It looked like we were going to make it. There were time to think about things. And I remembered this conversation. And so I called up his widow, called up his family and said, "Do you remember this?" And they said, "Yes." And I said, "Well, was he cremated?" "Yes." Did the family save, or did he leave behind any instructions about it? They said, "Oh, we've been waiting for a phone call like this. We have this. We'd love to send it to you. Yes, could you do this?" And so we built that little box that you see there and bolted it into the spacecraft, and the family sent a bit of his ashes that had been stashed away for just this purpose if the opportunity ever came. And I wrote the words that are on that little plaque, and we got a little bit of Clyde sent on its way out to the planet that he discovered in 1930 as a result. It was a really touching thing to do for his family and his memory. And it was kind of a connection for all of us. It was a little larger than life, to be honest with you.
Yeah, very powerfully moving aspect of the mission. So fabulous. Just want to, I know we're moving pretty fast with time. Is it okay if we go a little bit over, Alan, at past 10:15 Eastern?
Sure, if you like.
Because I want to get I want to get our audience questions in. I just want to touch on a few other aspects before we just talk about the mission itself. Can you tell us a little bit about, you mentioned about the 2,500 people that made it all possible, and obviously a lot of companies were involved. Can you touch a little bit on the New Horizons team? I've got one picture up here of the team, the science team, actually out at the Launch Complex 41 there in front of the Atlas V rocket, and a picture of Alice Bowman and Kimberly
That's Kim
and
Inico on the right.
Yeah.
Yeah. Well, spaceflight's team sport. There's no space mission that I'm aware of that's ever been done by a single individual. Even when I was doing suborbital sounding rockets, it took a whole team of people, from the launch team to the science team to the instrument team. New Horizons is a really big team, like a lot of similarly sized missions. $1 billion. That money doesn't get launched into space; it gets spent on the Earth. In our case, in the United States, at universities and federal labs and contractors all around the country to get the job done, to build a rocket, to build a spacecraft, to build the scientific instruments, to build a mission control, to get all those lawyers through the paperwork system with 42 state and federal local agencies, all that. It's a big team of people. And in the case of New Horizons, we were very fortunate. We were doing something that really captured people's imagination. Farthest exploration of worlds in history, fastest spacecraft ever launched, a chance for people in my generation to do what had been commonplace in the 60s and 70s, which is go to a whole new planet. But by the early 2000s, Pluto was the last train to Clarksville. It was the only game in town for something like that. So we had the pick of the litter for talented people and dedicated people. And, we asked people to sign up for the whole ride, not just for a couple of years to be a part of it, but to get it launched and get it flown across the solar system. And to this day, the core team of people that we signed up in 2001 are still, for the most part, leading that mission. The same engineers, of course, many less than it took to build it, now that we're just a flight team. But our lead mission systems engineer has been with the thing the whole time. Project scientists and most of the science team go all the way back to the beginning. Our long-term project manager, Glenn Fountain, only finally retired way later than most people retire, only really put his pencil down and really actually left the project, if you can believe this, about a month ago. And he turned 65 quite a while back. And our mission operations lead, Alice Bowman, there on the left, and I can go on down the list, have been with us all along. And it's been it's almost like a family in many ways. We've seen each other's kids grow up, and all the successes and tragedies that happen in families over a couple decades. And it takes a team, and I think New Horizons is a special, very magical team that really did something against the odds. Because when APL won that mission with us, a lot of people said to me, you won, but you lost. You'll never get it funded. You'll never get it built on time. NASA's not giving you enough money to do this. You'll get canceled because you'll run out of money, or you'll get something built, but it'll fail because you didn't have enough money. You'll never thread all those needles. And this team of people threaded all those needles. And as I said, referring to that July 4th, 2015 event, again, they made something very hard look pretty easy, but it was very hard. They pulled this whole thing off, and I just don't know how you could be any prouder of a group of Americans who did something against the odds and did it because it was the right thing to do.
Right. Fabulous. Let me show a picture of the launch here. So I guess that was an exciting day as well.
You think?
See, I can only tell you my experiences having worked on a fighter aircraft, and seeing it fly for the first time was probably one of the greatest things it could, I could be involved in. So I can't even imagine something like this.
Well, you look at that picture of the launch vehicle there, the Atlas, and it looks like one of my Estes model rockets, but it's actually 225 feet tall. It weighs millions of pounds, and it gets up off the launch pad and goes supersonic in 28 seconds, and is in Earth orbit 8 minutes after launch. And if any part of it goes wrong, that's the end of what at that point had been 17 years to get a Pluto mission funded and then built into the launch pad. It all depended upon that one launch. Everything was riding on that single day, and it worked flawlessly.
I want to show the voyage a little bit. If you could just talk about those 10 years and 3 billion miles to travel.
Well, when we first got launched, 10 years seemed like, oh my God, my little kids will be grown. It's like I can't imagine 10 years from now but it was a pretty uneventful voyage in terms of anything harrowing, except for that one event right at the very end, which we recovered from. But I have to put it in scale. When Voyager flew across the solar system, their flight team, you count everybody, it was 450 people. And of course, between the 70s when they got launched and the 2006 when we got launched, technology come a long way, and automation and computers helped a lot. But we were 50 belly buttons, 50 people, for flight control, engineering, science team, everybody. 10 times smaller than the Voyager team. We had to do essentially the same thing as navigate a spacecraft across the solar system, plan a flawless flyby, and pull it off. And because we were so many less people, it took the entire 10 years to get all that done. There was never a year that we really took time off, or really could. People felt like it was a 10-year sprint. It was a lot of work. Even though the spacecraft was hibernating a lot of time, the team was never hibernating because we were perfecting the way that we flew it and planning the assault on Pluto, and making all that software bulletproof, and doing thousands of simulations of one sort or another to make sure we worked all the bugs out. And it was a very intensive 10-year journey across the solar system.
Right. Can't imagine how exciting it must have been. So I saw this picture that you could just tell from the smiles on your faces what kind of a day it was, right?
And that was the very next day when the first high resolution images were coming to the ground. And those are members, mostly that's the science team. A couple people from the public affairs team are also there. And Andy Chaikin, who some of you may know,
who's
a space historian and screenplay writer, book author, who also is a very talented geologist, is in that picture. And I remember the image that we were looking at on that screen. You can't see it, but it was just spectacular to see how much personality that planet Pluto had, and the complexity of it that no one had really anticipated.
I have a few images that I just want to share before we get into some of the audience questions. Oops, let me go back here. So this one of Pluto and Charon there from, as you're approaching it. Is this a composite photo, or that was done?
This photo is actually two photos.
Oh, it is two photos. Okay.
Yeah, and they're put together to scale, but the two objects are far enough apart you can't fit them in one frame. So photograph one and then the other. Or
Right.
with one of our cameras, it's like a push broom, so you scan it across and build up the entire image.
And then you have Charon there. What is that red spot at the top?
It's the first uh, polar region. It's kind of an anti-pole, right? Instead of being bright like Antarctica or the polar caps on Mars, this is a polar cap that's actually dark. And what it's caused by is the fact that Pluto's atmosphere is escaping. And the primary constituent that escapes is methane, which is a simple hydrocarbon made up of one carbon and four hydrogens. And as the methane escapes everywhere, Charon gets in the way of some of it, and the methane sticks to the cold surface. And at the poles where it's coldest, it can't hop around and be lost to other processes. It just stays there, and the sun bakes it, not thermally, but with radiation that causes the methane to photolize into longer chain hydrocarbons that have that reddish color. And so ultimately, that's material from Pluto's atmosphere stuck at the poles of Charon, which itself is unlike any other place in the solar system.
It looks kind of rough.
Well, it's a very rugged world, and this is a big
Yep.
place. The distance from one side, say on the west to the east, is Charon's about the same diameter as the state of Texas is long. I often think of that big canyon system that runs across as just I-20 running across Texas, right? From El Paso to Beaumont.
Right.
That's a very long drive if you've ever done it.
Oh, yes.
It's a very rugged world with the biggest canyon in the solar system.
And I think the next shot is what you called the fail-safe image. Is this just in case something happened to the spacecraft? You wanted an image?
We wanted to get one image down on the day of the flyby in case for some reason we couldn't, predict that something would happen that prevent us from getting all the real voluminous data. It's kind of like, my idea was, one of the first things Neil Armstrong did on getting to the surface of the moon was
Scoop the soil, right?
Contingency sample. And they put that up in the lunar module. And then they went about the business of setting up the flag and the experiments and talking to President Nixon and then going out and getting some more samples. But that was just in case,
Right.
somebody sprung a leak in their spacesuit or something. They had to hurry home. They had a little sample of the moon to show for it. And this was the same idea. So we got that back on flyby day. We got it shipped off the spacecraft. It took hours and hours to cross the solar system and get it to the ground. But this was our fail-safe image.
Right. And then another beautiful image there. What's it called? The Sputnik Planum?
The big white area is a big glacier. It's called Sputnik. Most of the early names that we put on Pluto were the names of pioneering spacecraft, because I felt like we stood on the shoulders of giants and making the farthest exploration. We should honor the pioneering missions that came before us, whether human or robotic. And Sputnik was the very first satellite. So that glacier is named for it. Now, this isn't an image. This is actually a composite of mini images. It's a computer wrapped on a sphere so that it gives you the projection as if you were riding on the spacecraft, and what the view would be like, except we stretch the colors to make them more vivid here. So Pluto looks more like the previous image to your eye. This is really meant to bring out the subtle differences in color from place to place.
Right. And then we've got a closer image of, I guess, they're water ice mountains and an ice volcano.
And actually, some of the scientists on our team, most prominently Dale Cruikshank, who for a long time was at NASA Ames, but retired from there, have found evidence of many other places on Pluto that tell the tale of icy volcanism on the surface. This particular volcano, whose caldera is in the lower center portion of the field, is about the size of Mauna Loa in Hawaii. It's 150 kilometers across. The caldera is about 14,000 feet above the plain off the caldera. It's very similar to Mauna Loa in that respect in scale.
This is just a, I remember you showed this when I saw you at the Intrepid. Just an amazingly beautiful image.
Well, it's my favorite image of the whole flyby, even though it's scientifically probably not the most important by a long shot, but it's Pluto backlit by the sun. And you can see Pluto's atmosphere illuminated by the sun that's on the other side. And the reason I like this so much, is it's kind of like the Apollo Earthrise image, that was so powerful in saying we really put humans here at the moon to see something you could never see unless you were there. You can only get this image of Pluto backlit by the sun by being on the far side of Pluto.
Right.
And so this was the we done it moment for Alan. This was the crowning achievement of the exploration, was a picture from the far side of Pluto.
Fabulous. And I know now you're in the Kuiper Belt, and again, a great effort to keep the mission going. And I just happened to see this image. I think it's called a Arakoth. Is that how you pronounce it?
It's Arakoth. It's
Arakoth,
a Native American word, and it's called Arakoth.
It looks like a snowman, actually.
It does. You have to just to be clear. It looks like it's as big as Pluto because the way it's projected here. But it's actually tiny. It's like the size of one mountain on Pluto.
Oh, really? Okay.
Yeah. This is a little thing called a planetesimal. It's a building block of planets like Pluto. Nobody had ever been to one in the outer solar system. New Horizons did that. And it taught us a lot about how the planets get formed out there, which we could go into if we have time. But if you want to get to audience questions, I better.
Yeah, one more image to show, and then we'll get to the audience questions, because I just wanted to, you're in the Kuiper Belt. I saw this on the APL site. I think that I took this a couple days ago, so I know it's further away, but it shows where New Horizons is today. And I know some people had asked, how much longer will you mentioned kind of it could go to 2050, but it just shows how far away it is from Earth at this point.
I like to make the analogy that if you reduce the solar system to the scale, that every time you go as far away as the Earth-Sun distance, it's another house on a long street, like a neighborhood street.
Right.
Ours is one astronomical unit, one Earth-Mars distance, Earth-Sun distance away. It's the next house over, and Jupiter's 4 houses over, and Pluto's 30 houses down the block from the sun at the time we encountered it. And our spacecraft is now almost 60 houses down that block. So we are really far out there. Of course, the Voyagers are even further because they had a 30-plus year head start on us. But we are really, really far out.
Very good. So let's get to some audience questions now. That was great. I'm just going to go to the Q&A, let's see. I'm going to a couple questions that came in from a space science teacher. Given the many amazing targets in the solar system, how likely are we to get a return mission to Pluto in the next few decades?
Well, there are a lot of good places to go, and not enough money to go around. Fortunately, the rise of commercial spaceflight has opened up new ways to do space missions, and I think there'll be a lot of commercial scientific missions going forward. There already are a lot of those for studying the Earth, where there is a marketplace. I think there'll be a future where planetary exploration will be done on the commercial side too. I think we're going back to Pluto. We're going to go back with an orbiter. That's what makes sense to do next. Now, is NASA funding that? No. Is anybody working to build that spacecraft? Not yet, because there's no funding for it. But that day will come, and there's a lot of interest in it in the planetary science community, not just here, but in the planetary science community around the world. So its time will come.
And another question that came from the teacher and their students, is there any rain or precipitation on Pluto? And if so, how can we study it?
Well, it's too cold to have liquid droplets in the atmosphere. But there is evidence that in the past, Pluto had a thicker atmosphere and that it was high enough pressure in that atmosphere to have liquids on the surface. We looked very hard for clouds and the kind of phenomena that the question's about. We couldn't find any evidence of that. But the thing about Pluto is that we know that it changes a lot over time. We only saw one frame in that movie. There's pretty good forensic evidence of, we even found a frozen lake in a hanging valley on Pluto. So we know that there are epochs in the past where that kind of phenomenology might well have taken place. It wasn't when we flew by, but millions or billions of years ago, perhaps.
And let's see, another question here from Carl. Let's see. Well, there were a number of questions that were submitted, so let's talk about the elephant in the room, the dwarf planet thing. I know it happened when your mission was already on its way, and I knew there were a number of questions that came up that people submitted, and Carl is asking here, do you believe that Pluto should still be in the Planet Club? What's your reaction to that whole controversy? Because I know you give some pretty good explanations in the book about even the true definition of what a planet is.
Well, I mean, we could go on about this for an hour and a half.
I'm sure,
but we don't need to, and it's getting late in your show. Let me just cut to the bottom line. Really, what happened now almost 20 years ago at that meeting of astronomers has never ceased to be controversial. And in the field of planetary science, virtually no one buys that story. It's almost universal. Phil Metzger, who's a professor at down in Florida, where you are, in Orlando, it's actually done a big literature search and found that there are no scientific papers that use the astronomer's definition. No one buys it. It's unfortunate that the press kind of lapped it up and said, well, a bunch of people voted. That's not what we do in science. We don't vote on the theory of relativity or evolution or continental drift or what is a planet. Voting isn't a very good process in science. And anyway, the press picked it up and they sort of made it the story of this underdog that got squished. But the fact is that scientists never really bought into that. And unfortunately, if you read articles in the press or if you read textbooks these days, it's as if it's a fait accompli in the other direction, and nothing could be further from the truth. Planetary scientists call these little guys planets too, because we don't know what else to call them. And I guarantee you on Star Trek, if one of them showed up in the viewfinder, you'd say, oh, look at that planet they showed up at. I hope that's enough. We can go on.
Absolutely. Like you said. So let me get a few other questions in, and then we can get to the virtual door prize.
Mm-hmm.
I see a question in there about, is the instrument named Alice and not to Alice Bowman, or is that just a coincidence?
It's a complete coincidence. We did name most of the instruments on New Horizons for names. There's a Ralph, there's a Lori, there used to be a Pam. And it's funny, some of those names, we have people with those names on the project. So sometimes I refer to these, it's Ralph the guy, not Ralph the gadget, because we have an instrument named Ralph and we have a guy named Ralph, and it's the same for Alice. It was not named for Alice Bowman. In fact, Alice is a name we chose many years before New Horizons for a whole line of ultraviolet spectrometers that began with the ESA Rosetta mission when the first Alice flew. And now we've flown 6 of them around the solar system. I just like pretty names. Not everything has to be an acronym.
Right, exactly. Another question. I'll add to the question. How fast is New Horizons traveling, and what was its top speed?
Top speed was when we did the flyby of Jupiter, which added about 5,000 miles an hour to our already high speed. And as we climb out of the sun's gravity, we're very slowly slowing down. But we're basically at our final speed now. We're almost from an energy loss standpoint, we're almost out of the solar system, and traveling about 14 kilometers per second. So you can work that out into miles per hour or furlongs per fortnight or anything else you want. But we travel about 3 times the distance from the sun to the Earth every year. And that's a pretty good rule of thumb. As long as New Horizons is operating out to mid-century, it's about the same number every year.
Right. I saw another question there. How was the name New Horizons chosen?
I chose it. We wanted to have a good name for our proposal, and we debated a lot of names, and I wrote a story about this. We had lots of names, and often we'd like a name, but then somebody would find some reason it had some awful connotation that we hadn't thought of or whatever. And one day I was out running in Boulder, Colorado, where I live, and I stopped because of a stoplight after 3 or 4 miles and looked back at the mountains to the west. And it just came to me, how about New Horizons? That's what this mission's all about, is going to new places. And it's also New Horizons for a new way of doing business, to do it less expensively and quicker. And when I presented that to the team, it came out on top. And so we named it New Horizons, and we run the proposal. And I love that name. And that's all there really is to the story. Right. Again, not an acronym, it's just a pretty name.
Interesting question here. Do you believe the success of the New Horizons was entirely the result of human effort, or do you believe that part of it was the success was providential? Interesting question.
Oh, I don't even know how to answer that. The first thing I think is that there's no question that luck shined upon us a number of times. But I think you make your luck, and New Horizons team worked really hard to succeed. And sometimes we got good breaks. And that definitely played a role. But the human effort was unimaginable. When you put thousands of people together, all working to a single goal for years and overcoming challenge after challenge, political challenge, funding challenge, bureaucratic challenge, technical challenge. It's amazing what human beings can do when they put their mind to it. It makes me an optimist for the future.
Let's see. I'll get a couple more and then we'll cut it off. I don't know if there was someone who had raised their hand. I thought someone had, because sometimes we turn on the microphone. But let's see if is there any evidence of tectonic activity on Pluto or any of its moons?
There is. As a matter of fact, tectonic features are seen across the surface of Pluto and across the big moon Charon. The big canyon system that I talked about that runs all the way across the girth of that image is a tectonic extensional belt. So there's plenty of evidence of tectonism, and not just at Pluto and its moon Charon, but across the entire outer solar system. This was not surprising. Maybe it wasn't a slam dunk before we got there, but it wasn't surprising to find tectonics. Things like volcanoes, evidence of past liquids, very young surfaces of very large scale. Those things were much more surprising.
Very good. I saw there was a question about all the acronyms of some of the scientific experiments. I can share. I'm going to be sharing a link, everybody, at the end that you can find all that information out. So no sense to talk about that, taking the time to talk about each of those. Let me see. Does anyone want to raise their hand and ask a question directly? We can do that right now. We got 1 or 2 more minutes to do that. So let me see if anyone does that. I see I do see a couple hands up there. Okay, I'm going to allow, let's see, we've got a few of them. I got Ronnie. I'm going to let Ronnie ask a question. So Ronnie, I'm going to allow you to speak. Let's see. Okay, Ronnie, you might, yep, go ahead, Ronnie. Can you hear us?
Yeah. I've been holding back on asking this question. I was wondering why Planetary Society.
Ronnie, hard to hear you.
Can you hear me now?
That's better. Yep, go ahead.
Sorry, I got computer and phone. I was wondering why Planetary Society didn't get involved.
Planetary Society was helpful, and I think you're talking about in the most recent Save for New Horizons, which National Space Society really led. Planetary Society was very influential in getting New Horizons started, and they helped us in this battle too. They did not take lead, and that's probably why I'm on this show instead of a Planetary Society show. But NSS stepped forward, and we hitched our wagon to NSS, and it worked out spectacularly well. Really turned the situation around and saved New Horizons.
Thanks, Ronnie. We've got one more question from Matt. So we'll let you take the last question here. I'm going to let you talk. You might have to unmute, Matt.
Yep, I'm unmuted.
There you go.
Yeah, so my question is, what's next for New Horizon? Are there any more targets in the Kuiper Belt that you're heading towards? Or
well, first I should tell you we're very busy, that the spacecraft is very busy doing a whole variety of different scientific investigations of the Kuiper Belt and of the universe. And all the while, we're looking for another flyby target. But the problem that we have is that we're much further out, so they're much harder to find, and we have very little fuel to do the divert maneuver. So we have to find one that's within our fuel reach, and it's the combination of being farther out and harder to find, along with very little fuel. About 1/10 of a tank of gas is all that we got, and there's no filling station to put more in the tank. So the odds are against us in finding a flyby target. But we have the best people in the world on it, and the very best instruments. And maybe we'll get lucky and find one. But even if we don't, we're still studying Kuiper Belt objects every year that we pass, and doing things that you can't do from the Earth or James Webb or Hubble or anything, because we're right there, and doing astrophysics and heliophysics that can't be done except by a spacecraft that's out there at this distance. So it may not be as flashy as the flybys of Pluto and Arikov, but the science is spectacular, and it's not going to be replaced by any other spacecraft for decades, because nothing else is coming out this way. And if we get a flyby target, no one's going to be happier than yours truly, and none of you will have to wait. We will shout it to the rooftops as soon as we know it's there.
Very good. Thanks, Matt. Alan, thanks. That was the last question we'll take. And what I'd like to do is make a quick transition here to do our virtual door prize, because I know we're running a little bit late, and we still have quite a few people who are still on. So let me just switch out my PowerPoints here, and then I'll get ready. Now, it's funny, I did, let me show this here. Okay. I'm going to share my screen again. Oh, there's my, there we go. And I did find this cute cartoon here. I don't know if you'd seen this one. Even Pluto's reading your book, okay?
That's cute.
Yeah. So, so now, everybody, thanks so much for joining us this evening. We're going to have 4 copies of Chasing New Horizons that are going to be signed by Alan. And I've created a random number generator on my iPad here. And I've got the entire list of everyone who's registered. And again, we've got about 80 people who are still on tonight. So hopefully you'll be here when I call the number. So I'm going to do the first one. So that's number 19. I've got David Freitas. David, are you on? If you are on, just put a note into the chat, and we can see if you can get you your book. Let's see. Let me make sure I can see that I can access the chat here. Okay. David, anything? I don't see you. This is always hit and miss. We did this last week as well, and some people weren't on. So David going twice. I'm going to do another right here. Let's do that. And that is number 72. So Tom Melton. Tom, are you on? Okay, I don't see anything in, I'm going to stop sharing everybody here for a second. Okay, we'll do one more. Hopefully we'll find some people who are still on. Gary Gutt, G-U-T-T. Gary, are you on? Just put a note into the chat. Okay, I don't see anything there. Sorry, everybody. We're hit 3 strikes already. Okay, and the next one is number 93.
Actually, Bert, you got to respond.
Oh, Gary, there we go. Gary, gotcha. Got you, Gary. Thanks so much. I'm going to just mark you down. Came in a little late. Thanks, Gary. Okay. Okay. Very good. We'll do one more here. And Alice Kelly. Alice, are you on? Great, Alice. We got you. Congratulations. Just marking you down there. And let's see. We've got 109. Yada Rithvik. Yada Rithvik. It's R-I-T-H-V-I-K. Yada. And while we're waiting for that, I'm going to get the next number. Okay. I don't see Yada responding yet, but I'm going to do one more. Okay. I've got a Grace Rober. Grace, are you on? Okay, Grace, fabulous. So that's 3 confirmed. We've got one more, and we'll do this, hopefully this last one. Okay. And John Daigle, one of our NSS volunteers. John, are you still on? Oh, we got it. Okay, we've got all 4. Fabulous. So everybody, I'll be following up with you to arrange to get we have to get the books back signed, and we'll get them out to you as soon as possible. But I'll be following up to get your addresses and make sure we get them settled. So everybody, we are going to close out the evening. I know we went a little bit late. I definitely want to thank Alan for just a really fascinating discussion. We really appreciate you taking the time to be here with us tonight. So thank you so much. I would also, of course, like to thank Hoyt Davidson for being here as well, and for all the effort you made in saving New Horizon and that a fabulous petition. So thank you, Hoyt. I want to thank my colleague Fred Becker and Larry Ahern for all they do to support our space forums. And of course, a big shout out to our CEO, Anita Gale. So it's been a really great evening tonight, and just a lot of fun. So let me close out with one last slide here. And if I can just get there we go. I will share my screen one last time, everybody. And there we go. And you all recognize my going outside. So again, thanks everybody for being here this evening. It was a lot of fun, really interesting. Again, thanking Dr. Alan Stern, not only for being here tonight, but for everything he's done for advancing space exploration and especially the New Horizons program. As you as audience, thank you for joining us. For those in our time zones, wishing you a great evening. If you're in tomorrow's time zone, have a great day. And of course, everybody have a great weekend. Stay safe. We will see you next on November 9th for another interesting space forum. So everybody, wishing you well and thanking you again for joining us. With that, just want to say good night. And Fred, you can turn off the recording now.